let's see if you guys were able to do it. It says a line passes through the origin with slope m, so we got the y equals mx line. Okay, so y equals mx. And again, visualizing this, it says we want to find the slope where it's tangent to y equals ln of x over 3. Now, ln of x over 3 is probably not going to be, or actually it is stretched by a factor of 3, because remember when it's in the x, it's actually the reciprocal, so it's really steep. So then what I'm going to do is find that. I think what always happens here, if I'm not mistaken, in this case, a natural log y is going to end up equaling what? Does it equal 0? Does it equal 1 again? Okay.
How do you get to equal 1 though?
Okay, so here you found you're trying to figure out, you got to figure out this point. I know it crosses through 0, 0, right? Okay, so first of all, find the derivative of y equals ln of 3x, correct?
Yeah.
Alright, so we're going to have y equals 1 over 3x times 3.
It's x divided by 3.
Oh, it's x divided by 3? Okay, so natural log of x divided by 3. So it's going to be 1 over x divided by 3 times what? Times 1/3, correct? Okay. So then we're going to have y prime is going to equal, if I multiply by the reciprocal, that's 3 over x times 1/3. What happens to the 3's? Cancel, so we get y prime is equal to 1 over x again. So then if we plug this in to this equation over here, our equation for the line, because we know that's the slope of the tangent line, that's the slope, m. So we get y equals 1 over x times x. What happens to the x's? We got y equals 1 again. And it seems like it's going to happen all the time on these natural log ones that way, unless I change it more. Then it'd probably get into where you probably have to use that 0, 0 to help you somehow. So once I get to that, then I know y equals 1, so now I can use that to find the x. Now I know the y value for this point, so what do I do now? Plug it in to get this. Would probably be a good extra credit question tomorrow, just so you know. So now we go 1 equals natural log of x over 3. What do we do now? E to the first is equal to x over 3. So what does x equal? 3e. But that's not enough. That's my x value. But I want to find the slope. I'm looking for what was the slope of this tangent line that goes through the origin. So I plug it into the what? So 1 over 3e, and there's your answer. Anybody get that? Good. All right, last thing I want to do here, and I'll spend a lot of time. I'll just do 2 problems real quick, and then we'll stop. And it's on the implicit differentiation notes that we're going to finish up today in class. But regarding class today, the only thing I'm going to do in class today is to keep the test tomorrow and to not overwhelm you in class today. Okay. Very quickly, I'll just do 1 or 2 of these problems here, and then you guys will probably finish here in just about 5-6 minutes, and then you guys can go. The one I want to do is 1 or 2 and then 3. Do you have a preference? Do you want to see quotient rule or product rule with factoring out the least power? Because this is the problem tomorrow that's going to really be a pain for people, okay? This is the one that's going to bother you. There's some differentiability stuff that'll bother you too tomorrow, but this is the main thing. Okay, which one? Quotient, okay. So let's just do number 2 with quotient rule. All right, let's go through it. Write it down with me. So f prime of x. Okay, derivative of the top is going to be what? 1. There's not a lot of rewriting we can do here. That's why I'm just jumping right into it. Okay, so we're going to have 1 times the bottom, x squared plus 4 to the what? 1/3 power. Minus, the quotient rule is always minus. So derivative of the top times the bottom. Minus derivative of the bottom, which is what? 1/3 x squared plus 4 to the what? -2/3. Like some of you are going to start taking the derivative of the inside before you should. Times 2x times what? X. I feel like we've done one like this. Oh well. We square the bottom, what are we going to get it to? 2/3 power now. And as I do this, cleanup. What else do you not like here? We talked about the other day. We had a problem similar to this. We have an eyesore. The 1/3. So how can we go ahead and get rid of the 1/3 and clean the problem up at the same time? Multiply top and bottom by what? 3. And then we're going to factor out least power in a second. So we're going to have f prime of x. It's going to be equal to, if I multiply top and bottom by 3, that's going to give me 3 times x squared plus 4 to the 1/3. Multiply this by 3, we're going to get the 1/3 is going to cancel, the 3 cancels, so I have minus 2x squared times x squared plus 4 to the negative 2/3. And then on bottom of 3, we'll have x squared plus 4 to the 2/3. I feel like we always do the exact same problem. I think it was maybe one thing different, but it doesn't hurt to go through again. Alright, now this is the part tomorrow that will stick some of you. What do we do and how do we do it correctly? We factor out a what?
X squared plus 4 to the negative 2/3.
And how do you know tomorrow you're going to do this? Because if you ever do product or quotient rule, and then when you're doing the product and quotient rule, there's a chain rule in it, you're always going to factor out least power. No exception. Okay? So we're going to factor out x squared plus 4 to the what? Negative 2/3. Does everybody, don't let me go any further if you do not understand how I got negative 2/3. I'm taking out the one with the smallest what? Exponent. Then we're going to be left with, if I take this now, divided by this, what are you going to get? 3 times x squared plus 4. To the what power? First. Now how did I get first power? Since I'm taking what I circled and dividing it by what I'm factoring out, the 3 doesn't cancel, and then when you go x squared plus 4 to the 1/3 divided by x squared plus 4 to the negative 2/3, you're subtracting the exponents. You're going 1/3 minus a negative 2/3, which is 1/3 plus 2/3, which is 3/3, which is 1. Uno. Okay? Is everybody okay with that? If you can do that, you're going to knock this one out of the park tomorrow. But no surprises. This is what it is. Okay? Minus what?
2x.
Good. I'm almost convinced it's the exact same problem. Okay? All over 3 times x squared plus 4 to the what? Square the bottom. Don't forget to square the bottom. Square it, square it, square it. What is it? 4/3. I did?
Yeah.
I already squared it. Okay. I did square the bottom. Don't remember to do it twice. Okay? X squared plus 4 to the 2/3. I already squared the bottom. It was 1/3, so I squared it, became 2/3. Now, what can I do? Move this where? The basement, so that's going to be over 3 times x squared plus 4 to the what? 4/3. And then here, this will be 3x squared plus 12 minus 2x squared will be x squared plus 12. Any questions? Okay, does that help? Remember how we're going to do this tomorrow? And if you want to practice this one tonight. That's a product, well, it's a little simpler. It's not as hard to do. In fact, it doesn't have a fraction in it right away. And I don't think mine tomorrow has that dumb eyesore in it where you have to clear the fraction out. I think mine actually works out a little nicer. But you're going to have to factor out that least power. Now, let me do number 3 for you, and then we'll call it good. Because I think 4, 5, and 6. If you want to do 4, 5, and 6 before class, and then if there's any questions, just ask me. And if you want to try one, I can definitely do it. But I really need to spend most of the class on implicit differentiation and then going over what's going to be on the test. And then giving your assignment. Okay? All right, number 3, last one here. This one you would go f prime of x. How are we going to do this problem? Now, a lot of people said, well, I'll just square the top and square the bottom, and then I'll use quotient rule. I don't think it's going to save you any time. So I would just jump right into chain rule here. So it's going to be 2 times 3x minus 1 all over x squared plus 3 to the what power? First. That's chain rule. We're doing the derivative of the power first. Now when we get into the inside, what are we going to use? Quotient. What's the derivative of the top? Times the bottom, x squared plus 3. Minus the bottom, derivative of the bottom, 2x times 3x minus 1. And we did one like this yesterday from the homework, if you remember. Okay? Now we can combine these bottoms. So it'll be x squared plus 3 to the what? 3rd? Okay? Then we'll have 2 times 3x minus 1. And then this right here will be 3x squared minus 6x squared, which will be what?
Excuse me for this announcement. The National Honor Society meeting scheduled for this morning with Mr. Zimmerman will now be held tomorrow at the same time. Again, no NHS meeting this morning. Thank you.
There's your derivative. And see, I don't think that was a lot of work to do that. I think we did one similar to this the other day, and I think the numbers were just different barely. And we did one in the homework yesterday from, at least we did 3rd hour, 4th hour, I don't know if we did. Okay, any questions? Does that help? You feeling better about tomorrow? Okay, now one of the things I would do, and I'm going to let you guys go, so I won't go all the way to 8. But make sure you've looked at the derivative rules sheet that I put on Moodle, yesterday or the day before yesterday. It says memorize these or whatever. It says learn these. Make sure you look at that, and then if you click on that, and then Josh is going to put that Quizlet app on. Now, when you click on that app where it says Flashcardlet, it works online. Like you could start just studying the flashcards online, but I know most of you prefer it down into an app. So he's going to put the app up there today, and then when you get a chance to do it, I was leaving and he was heading out too. So, any questions? All right, everybody sign the thing.